Another important concept that we often use in SQL is the self-join. Self-join is basically when we join a table with itself. There are certain use cases where this is useful information to know, and one of those cases is when we want to display, say, the customer IDs of all those customers which belong to the same city. So say, for example, we have two customers which belong to a city, say London. So we have customers with customer ID 1 and customer ID 2, and then we have the city name as London. So in a sense, this is what we want to do. We want to display these three columns having these names. So the first column will have customer with customer ID 1, the second would have with ID 2, and then there'll be a column with the city name as London. And against these columns, we would want to display the appropriate values for customer ID, for customer ID 1, 2, as well as for the city. So this is our endeavor. First, let's have a look at the three tables in question. So we have the city table, the address table, and the customer table with us. So if we look at the city table, it basically contains the city ID and the name of the city. These two are the columns of interest. The address table will contain the address of that particular customer. It also has the city ID in it, so this is important if we want to join the city table with the address table. And then finally, we have the customer table, which will have the ID and the customer ID and the address ID. So we can easily see that the address ID here can join with the address table, which has the address ID, and the address table, since it also has the city ID, that can join well with the city table here, which will give us the name of the city. So that's what I've done in this particular query that you can see. Since we've already done views before, what I've done here is simply created a view called as customer city, where I am joining these three tables together. So customer with the address table with the city table, and it's creating a view called as customer city. So if we just do select star from customer city, you'll find that you have the customer ID as well as the city associated with that particular customer. So now our endeavor is to find or display the IDs which belong to the same city. So let's see how we can go about doing that. So I would basically want to create it in the same table here. So let's name this as, say, C1. Here what we would do is we would conduct a self join. So how we would do that is we would use the same table here and just give this a table alias as C2. So this has a table alias of C1 and this has a table alias of C2. We're just doing an inner join here because it's the same table. So if you're doing an inner join on, say, city, what it would do is basically join these two tables on all those cities which are common to the two tables that we are joining, in this case the same table. So say if we join this on city, so what we are doing here is, rather, we want the cities that are common to both these tables. We would join the two similar tables on city. So this expression here would join these two tables on city. And now we want to derive all the customer IDs from both these tables, which are not similar. So in that case, what we would do is we would do a C1.customer ID. So this will take a customer ID from the table number 1 here. And this sign here stands for not equal to in MySQL. So when the customer ID derived from table C1 is not equal to the customer ID derived from table C2, that means these two customers that we are taking are dissimilar and are two different ones. And we would want to display, say, both these customer IDs. So we would just do a C1.customer ID and C2.customer ID. That's what we want to display. And we can also choose to display the city that we want. So in this case, we can choose either city 1 or city from table C1 or city from table C2. Doesn't matter what we select, it'll be the same because we're joining it on the city column, which is common to both C1 as well as C2. So if we run this, we notice here that we get all the customers which are different and which belong to the same city. So now we have these two columns, customer 1, customer 2, as well as the city associated with those two customers. However, as you can notice, the first two rows are the same, just that the order of customer 1 and 2 are interchanged. So if we just want to display one of these rows, so either row 1 or row 2, and similarly the case with row 3 and row 4, what we can do is, instead of having this not equal to sign here, I think you would have guessed this by now, instead of having the not equal to sign, we can just have either the greater than or equal to sign. So if we just use the greater than sign here, it'll take only the second row from each of these entries here. So second row from the city of Aurora and the second entry from the city of London. So if we just run this, we'll find that we just now have one set of customers which are different in both the cities. So if we just do, if we just want to count the number of customers in all the cities, so what we'll do is just use our view that we've generated and just say we want to group by the city, and then we want to count the number of customers that we have in that particular city. So if we just run this particular query, you'll find that most of the cities have one customer here. However, if you just want to see say customers which have the maximum, or cities which have the maximum customer count, just try to order this by the count of the customer ID, and if we use the descending keyword here, it will basically give you an ordered list of cities. And here you can see London and Aurora are the only two cities which have count of customers as 2. So that's why when we run this query over here, we will find that we get two customers, customer 1, customer 2, which are in the city of London. Similarly, two customers which are in the city of Aurora. And these are distinct customers, as you can see by their customer IDs.